right. Linda Westfall is president, trainer, and consultant for the Westfall team, and tonight she's speaking on risk analysis and mitigation. Linda is president of the Westfall team and one of their lead consultants and trainers. Her specialties include software quality engineering, metrics, project and risk management, requirements engineering and management, peer reviews, testing, and process definition and improvement. Prior to starting her own business, Linda was the senior manager of quality metrics and analysis at DSC Communications. Linda has more than 45 years of experience in real-time software engineering, quality, project and risk management, agile, and metrics. She has worked as a software engineer, systems analyst, software process engineer, and manager of production software. And as we learned earlier, Linda and her husband, Rob, also have a very interesting fireworks hobby. All right, Linda, with that, I will go ahead and turn the floor over to you.
Are you seeing my screen?
Yes.
Okay. So as she said, I'm going to be talking today about risk analysis and mitigation. Change, where's my cursor? Okay, basic risk management process. Let's start there. If you don't know about the risk, you can't do anything about the risk. So the first step is going to be to identify the various project and product risks that you have. That feeds into the analysis step, which we're going to be talking about today. The main output of the analysis step is to take all those identified risks and prioritize them. Some risks will be so large that you may decide to avoid them. Other risks may be so small that you decide to just accept them and not do anything about them. So we're going to talk about that analysis step and what goes on there. Then we're going to be talking about the planning step, because once you've got your risks, you're going to decide what to do to mitigate them. So we're going to talk about various types of mitigation actions, because there's 5 basic ways of mitigating risks. Then once you've got your risk plans, you're going to implement your risk mitigation actions just as part of your project and watch them like a hawk, because over time, you may get additional information, what looks like a big risk early on. As you move closer and closer to that part of the project, it may get smaller and smaller. Of course, on the other hand, it may get bigger and bigger. And that information is going to feed into potentially reanalyzing or replanning for those risks. Tracking also may indicate a trigger that tells you that that risk is starting to turn into an actual problem. A risk isn't a problem, folks. A risk is something that might be a problem, but it might not be. So we're going to look at the possibility it turns into a problem, put metrics or meetings together to track our risks, and if the trigger says it is either become a problem or it's almost likely, it's got 100% probability, or now, even if it hasn't turned into a problem yet, it's almost certain it will, then we're going to kick off our contingency plans. So we'll talk about this risk management process, specifically focusing in on the analyze and planning mitigation actions during this talk. So let's start talking about analyzing our risks. We assume we've already identified them. We've got a list of risks that we want to analyze. And the things that we're going to analyze is the value of the perceived risk statistically, i.e. the probability that that risk is going to turn into a problem and its impact or loss associated with that problem if it does occur. We want to balance that against the perceived opportunity. We shouldn't take a risk if we don't have an equivalent gain or opportunity. So we're looking at the probability of the reward and the impact, i.e. the benefit associated with that reward. The way I like to explain this, let's say we have a 2x4. It's 4 inches wide, 2 inches tall, 10 foot long. I put it on the floor. So it's only 2 inches off the floor. If you can walk toe to heel across it without falling off, I'll give you 10 bucks. Well, let's analyze. What's the problem? Well, the problem would be that you fall off the board, right? What's the probability you fall off the board? Well, for most of you, it may be very unlikely. You can walk toe to heel across the 5-inch wide board, no problem. Me, I've had 7 knee surgeries, including 2 full knee replacements. I probably got a 90% chance of falling off that board because I have no side-to-side balance. Then we look at the impact if it does. Well, it's only 2 inches off the floor. If you lose your balance, you just step off the board. No harm, no foul. Of course, people may point and laugh if you're the only one that falls off the board. You may lose a little bit of self-esteem. I don't know. But, again, low probability, low impact. And what's the probability you get the reward? Well, the reward is the 10 bucks I'm going to give you, right? That's not a loss because you don't have it. I'm not asking you to give me the money. It's the reward because you'll get the money from me. And the benefit associated with that, well, 10 bucks will buy you lunch from McDonald's, maybe. These days, it's getting more and more expensive. But we want these things to at least be in balance before we're willing to go take the risk. Now, if I take that same board and put it between 2 5-story buildings, so it's 5 stories off the ground, now it's strapped down, it's strong, it's not going to break, it's not going to fall. But now, what have I changed? Well, I may have changed the probability that the problem occurs, that you fall, because it may be windy up there, or you may be so nervous that you're shaky. But what I really changed was the loss associated with it if the problem occurs. Because if you fall 5 stories, you're going to go splat. So nobody's going to do that for $10. It's just not worth it. But let's play fear factor, like on the television show. If you can walk across it toe to heel faster than anybody else, I'll give you $50,000. Anybody try it? Take yourself off mute. Anybody willing to try it for $50,000? Nobody.
No way.
No way, even for $50,000. And this is, again, this is usually where people start saying, yes, but can I have a harness? Yes, but can I have a airbag? And what we're doing is we're mitigating the risk. We've done the analysis. We really want that $50,000. The opportunity is great, but it's still not in balance with the risk. So to mitigate the risk, we have to actively attack the risk side of the equation, either by reducing the probability you fall. For example, we could get you out of your 5-inch stiletto heels down into a nice tennis shoe. We could make the board wider. We could even make you practice and train down on the ground until you get really good at it. Of course, the other thing we can attack is the loss associated with it if you do fall. We can get you that harness. We can put the big airbag there. We can make sure your life insurance is up to date. So if you do go splat, at least your family's taken care of. And that's where we get into the analysis and the mitigation. We're doing the analysis to decide if the perceived risk is in balance with the perceived opportunity. Now, for some people, the sheer act of taking the risk may be part of the opportunity. I mean, people jump out of perfectly good airplanes and play with high explosives like I do. But So part of the risk, the thrill of it in some cases is part of it. Of course, there's also people that are risk adverse. The opportunity has to be significantly more than the risk before they'll take the risk. So we're looking for some kind of acceptable balance. And if it's not there, we either avoid the opportunity or we attack and mitigate the risk. So to analyze a risk, we got to understand what the risk is. The first step in analyzing the risk is looking at the risk's context. Now, these are just some words to get you thinking about and discussing. For example, the conditions of that board between the two 5-story buildings might be it's a really windy day, or we just had ice last night and the board's a little slick. The constraints, you have to walk toe to heel across the board. The event, well, last night was your 21st birthday and you partied hardy till 2 a.m. and you're still slightly tipsy. All of these, we're going to discuss the circumstances, the contributing factors, etc., to decide whether or not what's the probability, what's the loss or impact if it happens. Now, another way of doing this is a fishbone diagram and use a cause and effect diagram. You're probably all very familiar with this from the quality arena. You're used to putting the problem in the head of the fish and then looking at things like the 4M's or the 6M's, management, manpower, methods, and machinery. Also, the other 2M's are materials and measurements. I usually don't use those because in software, we really don't have materials and measurements rarely affect our product, unlike the manufacturing arena. But you can use these same fishbone diagrams to analyze the context of the risk and put the potential problem in the head of the fishbone and then look at potential causes that make it more or less likely to turn into a problem or more or less a loss if it does turn into a problem. Of course, you can use any other analysis technique. The gentleman mentioned failure modes effects analysis, and you can potentially use that to determine, again, the probability that the failure occurs, the loss if it does. If you think there's only one cause for this potential risk, you can just use a 5 whys method. So there's multiple methods for looking at these analyses to determine the context of the risk. From this context, then, you're going to assign a probability. This can be qualitative. You can have a narrative like almost certain, very likely, likely, unlikely, remote. Or you can scale it on a scale of 1 to 5 or 1 to 10. Or if you need a more definitive, you can actually do mathematical, statistical analysis and come up with some kind of probability. Like there's a 50% probability you fall off the board or an 80% probability you fall. If we're assigning a qualitative probability, again, we may look at an actual probability, we may look at an index, etc. This is a repetitive slide. I'm sorry, I thought I took that one out. And then we're going to look at the loss. And there's several factors we need to consider when we look at the loss. First, the cost impact in dollars or effort hours to fix the problem, mitigate the problem. How much is it going to cost us? Is it going to cost us $10 or $10,000 or $10 million? Are there any schedule impacts? If it's a project-related problem, even if it doesn't cost us anything because we get people to work unpaid overtime or something to fix it, there may still be schedule impacts. There may be technical impacts. I'm used to working with software. So to mitigate a safety risk, There may be technical impacts like we have to do more verification and validation, which is going to take more time. Or there may be trade-offs between security and accessibility of our software. There may be other impacts we need to consider, things like corporate goodwill or market share, customer or employee satisfaction. Now, typically we take all of these and round them into some kind of either effort or dollar cost. But we have to consider the various different factors. And again, we can assign a quantitative value. It's going to be 2 weeks of effort or $20,000. We can do a narrative, catastrophic, critical, marginal, negligible, or a scale of 1 to 5, 1 to 10, what's ever appropriate. Now, when I'm doing these qualitative versus quantitative, I always go to the qualitative if that's good enough. If I can just take my risks and say, these are the highs, these are the mediums, these are the lows, and that's good enough, do it. Spend as little time and effort as possible. But if you need the more rigorous quantitative, then you're going to have to go to more rigorous techniques for doing your estimates. And another thing you can do is actually use a table like this, assigning some kind of qualitative value. It's catastrophic if any of the following are true. If it creates an unusable system, or it's going to cause schedule to slip more than 18 months, or if it's going to cause the budget to shift by more than 10%, again, whatever your values are, you can look at these various factors. If any of them are 5s, then we call it a 5. If any of them are 4s, we call it a 4, but if we have no 5s, etc. So we always go to the worst case, but it gives you some kind of range, some kind of guidance for assigning a qualitative value to the risk. And we calculate risk exposure. This is the probabilistic value of the risk, basically probability times loss. So we have our probabilities across the top, we have our losses down the side. If we're doing this qualitatively, something that's catastrophic and probable is a high, something that's negligible and remote is a low, and so on. It gives us a mechanism for ranking our risks by priority and loss, by the expected value of the risk. If we're doing it with numbers, we can simply, again, probabilities across the top, losses down the side, multiply. So it just gives us a number to rank things. Obviously, our highest risks are 5s and 5s, which would give us a 25 number. A 4 and a 5 gives us a 20 number, and that number, that risk exposure number, can be used to rank the risks. If we have a quantitative probability and loss, then we can just multiply. Folks, this is how you bet in a casino, right? The probability of winning times the amount you win is the expected value for that bet. So if you got a 1 in 6 chance, betting $1 should pay back $6 to break even. And that's what we're trying to do. We're going to take this risk exposure, which is the probabilistic value of the risk, and compare it to the probabilistic value of the opportunity. So for example, if we said we got that $50,000 for walking the board, risk 1 and risk 2 are both much more than that 50K. So we've got to go attack those risks if we want to go try for the $50,000. Or we can use some kind of prioritization matrix, again, to rank our risks. So we can look at various risks. We can look at the technical exposure. Again, the probability we have technical issues times the loss if we do. Cost issues, the probability we have a cost issue, the loss if we do. And we can rank on us on a scale of 1 to 5, 1 to 10, whatever. We can even add some kind of weighting factor and multiply across. In this case, risk number 2 would be our highest risk because it's got the highest total value. Then we'd rank it. Risk 1 would be the second highest risk. Risk 4 would be the third. Risk 3 would be the lowest valued risk here. So the intent of this analysis is to prioritize our risks and decide which of those risks we need to go mitigate. If the risk exposure is too high, we may want to completely avoid the risk. Most of you said, no way, I'm not getting on that board between the 2 5-story buildings. On the other hand, if we could reduce the loss or reduce the probability, we may bring it back into alignment. You may be willing to try it. And we can do the same thing. Another thing you need to consider is time frame, because you don't necessarily want to attack all your risks up front. Always wait till the last reasonable moment to go mitigate a risk. So we just scale them on a 1 to 5 again. If it's these are project risks, so if it's in the current phase of the project, we're going to score it a 5. If it's 4 phases away, we're going to score it a 1, because again, you don't want to take action too early because the project may get canceled and you spent that money mitigating the risk for nothing. Or the risk may get smaller and smaller. For example, if we have a probability that the test bed isn't going to be available on time, we don't want to mitigate that during the requirements phase because it just may end up being on time. We wait until the last reasonable moment to go mitigate that risk. We don't want to spend the money too early because the risk may never turn into a problem and then we've wasted the money. Another way of doing this is, again, looking at that time frame against the risk exposure. So even though risk number 3 has a higher risk exposure, we're not going to attack it immediately because it's a longer time frame to do it. So we're going to attack risks 1 and 7 in the current phase. We're leaving risks 3 and 5 till the next phase, risks 2 and 8 till the third phase, and so on, by looking at the risk exposure against the time frame. So let's move on now and look at the second part of this talk, which is talking about risk mitigation. We've got our prioritized risk list. There's 5 different ways of mitigating a risk, and that will feed into creating our containment actions and our contingency actions. So the first way to mitigate a risk is to decide whether we even know enough. And if we don't know enough about the risk to do good analysis, to do good estimations, we may be willing to spend money to go obtain additional information. We can do this by going and doing research. For example, if Acme is our subcontractor and the risk is they deliver a low reliability subcomponent for our product, we may do research by going and performing an audit of their quality management system to determine whether they even have the capacity and capability of producing something at the reliability level we need. If feasibility is our risk, we may go prototype something. If we're not even sure whether the process improvement we're looking at, maybe it's risky, maybe we go benchmark other companies that have similar process improvements and see how they've worked for them. We can do simulation, we can do modeling. And in fact, if you're doing a project, doing incremental development or an agile approach where you get those continuous feedback loops provide you additional information, but they may cost you something. So we decided we didn't know enough. We're going to go take some mitigation action, i.e. containment plans. Containment plans are plans we're actually going to implement as part of our project to go get additional information, and then we can make a better decision about the risk. Again, ACME may not deliver a subcontracted XYZ controller component with the required capabilities, the required reliability, and as a result, we're going to spend additional effort working defect resolution issues with ACME, doing additional regression testing. Two ways of obtaining additional information. Again, that capability assessment or the quality management system audit that I mentioned, or we can ask for references from past customers and check the reliability of previous ACME products. Might be two different examples of how to mitigate that risk. The second way to mitigate the risk is to just avoid it. None of you wanted to get out on that board for $50,000. The risk was just too big. You're going to do something else instead. So again, the risk is too big. I'm going to do a less risky alternative or avoid it completely. Now, the problem with avoiding the risk is you also avoid the opportunity. If you don't get out on that board, you have no chance of winning the $50,000. What is the Gretzky's quote? You miss 100% of the shots you never take, right? So, and not all risks can be avoided or should be avoided. Folks, you can avoid the risk of having an accident on the way to work in the morning by staying in bed, but that's not going to earn you a living. You know, you can't avoid all the risks. And avoiding a risk in one area may cause a much worse risk down the line somewhere else. For example, the easiest way of avoiding the risk of finding too many defects in your software late in the life cycle is to just not look for them. Stop testing. I actually had a boss once who told me, we need to stop testing now because we need to deliver in a month. And if you find any more defects, we won't be able to ship in a month because we can't ship with known defects. So he wanted me to stop testing a month early. Folks, all that's doing is creating a much worse risk of shipping all those defects that I might have found into the field where they're much more expensive to fix. They're much more expensive to our customers. It's just not a good long-term solution, folks. You want to be finding as many defects as you can early in the life cycle where they're less expensive. So go ahead and look for them. Again, how can we avoid the problem with ACME? We can develop the controller unit in-house instead, or we could switch to a subcontractor with a proven reliability record, even though their products are more expensive. So there's two different ways of avoiding the risk of ACME delivering a poor quality, poor reliable product to us. Now, if we take one of these alternatives, however, we've got to go back. If we're building it in-house, that's going to create a whole new list of risks. We're avoiding this risk, creating new risks. If we pick a different subcontractor, there may be different risks associated with that subcontractor. So you need to identify those new risks, analyze them, feed them back through the process. This is a very iterative process of doing risk management. It's not something you do up front and never do again. You're going to continue to do this throughout the project, throughout the life of the product that you're building. Of course, the third way of mitigating a risk is to make it somebody else's problem. The classic here is to go buy insurance and make it the insurance company's problem, but that's going to cost money to do, folks. Mitigating risks adds to the expense of the risk. So can we make it somebody else's problem? Can we buy that insurance? Can we hire another organization to take responsibility? Maybe we can hire, like I said, a more expensive team to build the product for us. Maybe we can hire somebody with more expertise than we have instead of building it in-house. We can transfer the risk to a customer. Microsoft does this every time you delete a file. They pop up that little window that says, do you really want to delete the file? They transferred some of the risk to you. You made a conscious decision to go ahead and delete it. They warned you. You can't be mad at them, right? Can you make it the subcontractor's problem or some upper management problem by escalating the issue? We did this back and forth with the software and the hardware and the users. There were hardware issues of the board going bad or something when we did telecom. So we constantly pinged and echoed that board. The software, when it wasn't doing anything else, would talk to the boards would talk back to the software. If they communicated correctly, we assumed the board was good. If it didn't, we put the board out of service. So we transferred the risk of a bad board to the software back and forth by doing that ping and echo. So again, just as an example, for Acme, low reliability, subcontracted component, we can transfer the risk to the subcontractor by building potential penalties into the contract. We actually, back in the day when we used to charge for long distance, and I worked for the telecom company, we actually, in our contract, if we had more than 3 minutes of outage per site per year on average, we owed them penalty money to make up for the lost revenue because the switch was down and they couldn't provide long distance service. So you can potentially transfer it to someone else. Of course, the one we do probably most often is put containment plans in place. We actively attack that probability or the loss. Again, we can put a containment plan in place to make the board wider. We can put a railing on the board. We can do training and have you practice down on the floor. These are actions that we're actually adding to our project. Yes, they're going to cost us money and time, which increases the cost of the risk. But if the opportunity is worth it, we can take those actions and still, if the opportunity is worth it, we can take those actions. So that's the fourth way. We can actively attack the loss if it does by, again, putting a harness out there, folks. But these are containment actions. You have to do these before the risk turns into a problem. It's too late when you're out there balancing on one foot, teetering, ready to fall, to run out there and try and put a harness on you. You got to do them ahead of time. Folks, you got to do nightly backups before the disk crashes, or you're not going to have the ability to restore the backup and get back in service if the risk turns into a problem, i.e. the hard disk crashes. So the fourth way is to come up with some kind of containment actions. Now, this may add additional activities. Again, we can do more testing if it's a product issue, or more inspections if it's a manufacturing issue. We can utilize different tools or methods. Now, we can continuously improve our processes, and that may minimize the loss if the risk turns into a problem. We can apply more effort or additional or different people. Instead of having a junior level person write the code, which may make that section of code more risky, If it's safety or security related code, you may want to put a senior person on it and let the junior person do the code that's a lot less risky. We can change the position of the activity in the schedule. We can move the activity forward, so if the risk turns into a problem, you got more time to manage that problem and put your contingency plans in place. However, we can also move it later in the life cycle, if possible. For example, if there's the risk I mentioned of the test bed being late, we can move the utilization of the test bed later in the life cycle by doing tests that require the simulator first while we have time for the test bed to come in. Or we can just add monitoring and tracking activities. For example, with ACME, we may assign a project engineer to participate in the requirements and design inspections of the software and the product, and to conduct alpha testing at the subcontractor site before they ship the product to us. We may even require them to give us metric reports, defining the amount of defects that they're finding late in the life cycle, so that we can predict whether or not we're going to get this much earlier and decide whether we need those containment actions. For product type risks, and this is true in software, but I'm assuming it would be true elsewhere as well, we can just do more verification and validation. For the low risk stuff, for example, we just may have one person desk check the software or the document or the work product. If it's more risky, we can have 2 or 3 people desk checking. If it is more risky still, we can have walkthroughs where the team actually meets and discusses the defects they're finding, where you've got the synergy of the team finding even more. Or we can go to full-blown formal inspections for the really risky stuff. They cost a lot more, but a good inspection on software with an experienced team can find 75 to 90% on average of the defects that exist in the product at the time of the inspection. And for really, really risky stuff, this health and safety related things, we can even go to multiple reviews. The same is true with testing our software or our product. Low probability stuff, we do less testing. High probability, high impact stuff, we do more testing. One of the ways of doing this is time block testing. For example, a low probability, we may only test that feature or function for 15 minutes or a half an hour. High risk, high probability, high impact components, we might test for several hours and run multiple cycles of testing with multiple samples. And the fifth and final way of mitigating risks is those contingency plans. So even if we don't need to take containment actions, the risk is low enough, we just accept it, we're going to potentially decide to put contingency plans in place just in case. These are the plans that you hope to never have to implement, but you got them just in case. These are your disaster recovery plans. Now, most disaster recovery plans, most contingency plans, take some kind of containment action just to put them in place. For example, it's too late when there's a fire in the kitchen to go buy the fire extinguisher. That's not part of your contingency plan. You got to go buy the fire extinguisher as a containment plan to make the contingency plan even possible. You've got to be doing the nightly backups to make the contingency plan of restoring your hard disk drive even possible. And finally, whatever is left over, and it's very difficult to remove all risks from all products, from all projects, from all processes. Whatever's left over, you're just going to accept. So whatever mitigation actions you decide to put in place, you're always going to re-estimate the risk side and compare it with the opportunity after the mitigation actions. So decide, have you reduced it to an acceptable level? And there's almost always gonna be residual risk. For example, right now there's a possibility that a meteor would fall from the sky, hit your home or wherever you are right now, and burn you to a crispy critter. But the probability, even though the impact is huge, the probability is so minuscule that we're not going to put containment plans or probably even contingency plans in place. So we're going to rank those risks using the analysis and then decide on, do we need any of these mitigation actions or can we just accept the risk? After we've implemented the mitigation actions, have we brought the risk down to an acceptable level based on the value of the opportunity? Again, the probability you get the reward. Again, I promised you $50,000. How many of you trust me? Just because you build the product and they think it's something that's going to sell well in the industry doesn't mean it does. So what's the probability you get the opportunity? What's that opportunity value to you? So with the contingency plans, we're going to accept the risk, but now we're aware. It's a conscious decision to accept it rather than an unconscious one where we're ignoring the risk. The easiest way to get hit by the bus in the middle of the street is to not look both ways before you step off the curb. The easiest way to have any risk turn into a problem is to not do good risk mitigation. Folks, if you don't actively attack your risks, according to Gilb, they will actively attack you. So we want to consider, do we need contingency plans, even if we accept the risk? If so, we may want to put some triggers in place that tell us that the risk is turning into a problem or it has already turned into a problem. So some examples here for Acme. We're going to accept that Acme is the best subcontractor for the job. We're going to trust them to deliver a high quality product. But we're going to put an early trigger in place to reassess the risks after the critical design review, where they look at the architecture and the component designs. Then we've got a second contingency trigger if there's more than 2 critical or more than 25 major defects during the third pass of system testing. And if either of those are true, then we're going to, the first one, we're going to reassess our risks. The second one, the contingency plan we're actually going to put in place is to assign an engineer to liaison with the subcontractor on defect resolution and implement our regression test plans for a maintenance release from that subcontractor before we ship our product. So again, these are just examples. So the goal of risk management planning, analyze your risks, consider all the alternatives, and there's 5 different alternatives. We can get more information, we can avoid the risk, we can transfer the risk, we can put in containment plans, we can put in contingency plans, and each of those may have multiple alternatives. So we're going to look at the alternatives and decide what's the appropriate plan for each of our risks that are high enough not to just accept. We're going to select which actions to take, develop our risk management plans, and then, folks, those risk management plans just get incorporated, the containment actions, as part of our project plans. We're going to change our budget. We're going to change our schedule. We're going to have different additional activities to implement the containment actions with assigned people, assigned resources, etc. And then we're going to have in our project plans a buffer to handle the contingency plans. Again, if the best time you've ever come to work in the morning was 15 minutes, You don't give yourself 15 minutes to come to work. You add a buffer to handle those risks because you're going to hit stoplights when they turn red. There may be more traffic than normal. There may be an accident. Again, you accept these things, you watch for them, maybe you track them by listening to the news in the morning, but then we have contingency plans as appropriate. If the triggers turn into problems, we got to have time and budget and resources to implement those contingency plans as well. And that's where the buffer comes in. Not all of your contingency plans will need to be implemented, but some statistical proportion of them will be. And that goes back to the analysis again. What's the expected value of each of your risks after you've mitigated them? You add those all together, that indicates the level of buffer you need for your contingency plans, because that's the expected value of those risks after mitigation. And that's where I say, let's open it up for questions. And I'll give you a chance for questions in just a minute. Here's a little bit more about my bio, but we've already read most of this. And I told you I would give you the website. It's softwareexcellenceacademy.com. If you go to that website, scroll down on the home page, there's a place to get yourself onto my email list if you're interested in attending future webinars, classes, those kinds of things. I send out announcements, and at any time, I have an automatic scroll down on any message to unsubscribe if you don't want to hear from me ever again. So there's a one-click unsubscribe. Try it, see if you like it. If you don't, you can unsubscribe. So with that, I will open it up to questions.
Any of you have questions for Linda, you can either unmute yourself or go ahead and type them in the chat and I will be sure to ask them.
And by the way, that's 2 of my fireworks. I built those.
Those are awesome.
This stand here, I know it doesn't look it, but it's 18 foot tall and 25 feet wide.
Wow.
And it's called, this is called a waterfall, the ones that are going down, and the ones that are going up are called gerbs or fountains.
Very cool.
And then these are Lanceworth pieces, the stars with additional gerbs.
Wow, that's pretty impressive.
That's part of my ground where I won Grand Master. I did a 4.5 minute ground show to Neil Diamond's Coming to America. And this is one portion of that. It had mines and comets and all kinds of things.
Very cool.
Any questions?
We do have one question in the chat. How do you separate product, process, and project risks? For example, would you place in 3 separate risk registers?
I don't, because maybe 2, because if I'm in manufacturing, then I'm typically considering process risks and product risks, the product that got produced by the processes. So I would put those together in one risk register. If I'm doing a project, the project risks for schedule and time and resources. The project also fails if the product that it produces is not of high quality or doesn't have all of its functionality. So if I'm looking at projects, I'm typically looking at the product produced by the project as well as the project risks. And I would want to keep them all together in a single register, because the more you separate them, the more they get lost or ignored. And then in every one, I talked about tracking in every one of my project meetings, my team meeting, my senior management meeting, my phase gate meetings, we talk about risks. And we use that single risk register. And the same thing from a manufacturing perspective, you've got your processes and the products being produced by those processes. typically you want to consider those together and review them periodically as part of your manufacturing tracking and control processes. Hopefully that answered your question. If not, re-ask it in a different way.
Yes, they said thank you in the chat. Do we have any other questions for Linda? Oh, I see Richard has his hand raised. So Richard, you're up next.
Yeah, this is Rich Comple from Flagstaff. I was just wondering, Linda, did you ever convince anyone to walk across that for $50,000?
Actually, yes. I had a gentleman once, actually, I gave this similar talk at the Fort Worth section a few years ago. And the gentleman's hobby was tightrope walking. And he says, if I can walk across an inch-wide rope without falling, I can for sure walk across a 4-inch-wide board. So yeah, he wanted the, and yes, I didn't give him $50,000. It was just an example, but he said, I'll do it. And he didn't even want it to be mitigated. He just said, my probability of falling is 0. So yeah, I had one gentleman once, but most of the time, especially in the classes and things where I give people more time to respond, it's usually, yeah, but can I have a harness? Yeah, but can I have a, so they're already thinking mitigation.
Yeah.
Folks, we learned risk management when we were kids. We learned to not run into the street after the ball without stopping and looking. We learned not to pull our sister's hair without an escape route.
Yep.
But somehow, when we get to our jobs, somehow we just kind of forget about risk management. And it's the easiest way to have your problems or your potential problems turn into real problems.
All right, we have a couple more questions in the chat.
Okay.
What path would you recommend for a traditional manufacturing quality engineer to develop into a software quality engineer?
Oh, that's completely off risk management. You already know half of it, because if you're a quality engineer, you know all the quality side of the house. Now, you are probably already a user of software. Everybody uses software all the time. So you're at least familiar with the basic concepts. Now, if you, that's a whole different talk. But when I talk about software quality, it's basically 6 major activities. The first one being developing the software part of your quality management system. How are we going to govern software? What are our software quality policies? Doing the management, governance, and oversight of the software part of our work. Then there's the software process engineers who are going to be defining the detailed processes as part of that quality management system and helping continuously improve those. So you could potentially, as a quality engineer, do those with very little additional knowledge other than, interviewing software people about what their processes are and then go documenting them for them. Now, things like doing the quality assurance where you're auditing, you've got to know enough of the vocabulary to not be baffled by their bullshit, to be blunt. You're going to have to learn software technology. What do they even mean by configuration management? What is testing? That kind of thing. Software quality control, a lot of your metrics, a lot of your configuration management things, you just got to translate that into software. So if I teach an introduction to software quality course in a lot of companies, and I tend to have 2 students. two types of students. The people that know software that are trying to learn the quality side, and the people that are in quality trying to learn the software side. So you're already halfway there. Get some books on software. I might recommend Pressman's book on software quality engineering. If you really want to get deep into it, the Certified Software Quality Engineer Handbook. Wait till September because the 3rd edition is coming out in September. Right now, I finished writing it, but it's in copy editing. And it has to go through 4 cycles of review. It's already gone through the first one, but there's 3 more cycles of review. But that book, now it's 800 pages, so don't get too intimidated, but it's a great reference. And it's got a lot of definitions, a lot of terminology. It's a basic intro 101, everything you need to know about software quality, based on the ASQ body of knowledge for software quality engineering. You know, I learned software, I didn't learn it in college. They taught you languages in college. That's 10% of the job. Everything else I learned on the job and by reading and studying and taking courses. You said there was another question?
There are a few more, yes. In risk management for medical device, we use ISO 14971. Is there something similar in software?
No.
No, okay.
That is a generic standard. Risk management's risk management's risk management. The only thing that I would say about that is when we talk about probability in medical devices, typically you're talking safety. And that standard very much focuses on risk from a safety perspective. Unfortunately, with software, the probability there's a defect there is unknown. Therefore, you got to make it 1, which means you're doing everything on loss rather than on loss times probability. So instead of that, instead of just using 1, which by the way, I think that's what that standard says to do, typically when it relates to safety of a software product, you look to level of control instead. Typically graded on a scale of 1 to 4. Level of control 4, which is the highest probability, is basically where the software is autonomous and time critical. An example of that would be the airbags in your car. If you have an accident, the software is going to set off those airbags, and it's time critical because they got to go off before you hit the steering wheel. There's no time to mitigate it. There's no time to say, don't do it, please, hit a button and stop it, right? The second level 3, level of control, is where you have software that is autonomous but not time critical. For example, a boiler. The software turns on the heat on the boiler automatically. If it could overheat the substance and blow it up, but there's time to notice and turn it off. There's time, or some other piece of software could be monitoring the temperature, and if it gets too high, turn it off. Or it's information that's given to human beings that's time critical. They've got to react instantaneously or they lose the opportunity. The third level is software that is not autonomous. A person is commanding the software and they can turn the command on and off at will. Or it's information given to a human being that's not time critical. For example, I have a blood sugar reader. I'm diabetic. I can prick my finger, I can take my, but I've got plenty of time to decide whether or not I want to react to that bad signal. My sister is a nurse, and they have automated dispensing of medications, but it's not time critical. They dispense the medication, but then she looks the medication up in her little other piece of software and compares the shape of the pill before she gives it to the patient. Because every pill has a different shape, a different labeling, a different color. So she makes sure that the software gave her the right medication. It's not time critical. So again, and then level 1 is not safety related software. And I know that's a long answer, but the more modern way of doing it with software is to use the level of control the software has and the ability to abort, in effect, as to replace the probability factor, because software is going to have defects. The probability the software fails is 100%. The question is it going to fail in a way that leads directly to an accident without having time to make a decision about it? Hopefully that answered your question. John, did you have something to say?
No, that was adequate for the audience, because you did a good example of, you've got 3 different cases there. So like you use the diabetic, which is a level 1, versus when you get into level 3, where it's critical performance, where it's life threatening.
Yeah.
So you have to go through extensive UAT testing, and that, not only the test independent as well as the product itself. Hillary, you're seeing another side of me you didn't even know, right?
You've got multiple sides, yes.
Yeah, so yeah, it was interesting because I had never been, I'd done the typical risk management like you were talking about from the software side. So when I got involved with product manufacturing, it was interesting when we got into it. But I remember the CEO saying he said, it's not about risk. It's all about how much we get sued. So I said, then we'll test everything. Thank you.
We have a couple more questions, Linda. What's the next step if the contingency plan doesn't work? Research a better one?
Yep. The problem is the problem's already occurred. And hopefully you've gotten a good contingency plan, a good disaster recovery plan. But folks, a disaster recovery plan can fail. And then you're out there making decisions on the fly. Hopefully you've done enough good engineering that your contingency plan is going to work for you. And this can be as simple as, if I get a flat tire, my contingency plan is I have AAA. I hope to never have to use it, but it's there. I've only ever used it once. But, it's a good contingency plan. I ran out of gas on the highway because I wasn't paying attention, and then an hour later, they brought me 5 gallons of gas. But I had to sit there for about an hour waiting on it on the side of the road. It worked.
Yeah.
But so hopefully you've engineered a good contingency plan. Hopefully your contingency plan isn't that you have a spare in the trunk of the car, but no jack. You have to have a good contingency plan. So hopefully you've thought of everything that you need to think of, and you've built a good one. But rarely can you eliminate all the risk. Yes, I can maintain my car. Yes, I can, still doesn't mean I'm not going to have a flat tire, or not pay attention on some long drive and run out of gas. But
Right.
hopefully you've got mechanisms in place for dealing with that.
Okay, we have a couple questions remaining. Someone said it's a great presentation and they're wondering if the slides will be available.
I can get them to you, yes,
Okay,
if you want. I'm assuming you've
if you get them to
recorded
me,
this
then
and
I
you're
will.
going to post it. But shoot me an email so that I've got your current, I think I've got your email address, but just in case,
Okay.
shoot me an email and I'll
Yep.
respond to it with a copy of the slides.
Okay, perfect. Thank you. The next question is, let's see, in software like you, oops, sprung forward too soon. In software, like you said, it may be difficult to quantify risks and benefits due to realized versus unrealized benefits. How do you work around this and communicate this to stakeholders? Do you have any further advice for quantifying these benefits? For example, improved user experience. So
It's like any
yeah.
other estimate, you estimate. What can I say? You gather as much information as you can, you consider all of the factors, and then you guess, based on the information you've gathered. Just like I go all the way back to the slide about context. All farther back than I thought. Again, just like on the risk side, talk about, what are the related issues? Well, is there another product in the field like this? What's my competition? Am I going to be the first out there with this product? Or am I competing in an industry with many other similar products? That's going to impact the probability I get my reward. The circumstances, contributing factors. Maybe my product is higher reliability than everybody else's. Maybe mine has a better user interface. Maybe it takes into consideration people with handicaps or other disabilities that would create a niche market for my product. What are the events? Well, you sell stuff just before Christmas. If your product is that kind of product, are there special events that would make your product more or less likely to sell? Any assumptions about what the market share even is? How many people would want to do? Are there any constraints? Again, one of my constraints selling my courses is I sell a lot to regulated industries. So, who is in the White House depends on funding when I'm talking to Department of Defense clients and that kind of thing. So again, you talk about it, you think about it, you look at all of these. You can even use, again, the opportunity in the head of the fish and what makes it more or less likely that that opportunity turns into a reality. And do these good analysis, good discussions, and then make the best estimates you can. Because we're all risk is all about the unknown. And we're trying to make the unknown at least as known as we possibly can.
Mm-hmm.
And if you don't know enough, then go to the first mitigation action, which is decide what you can do to learn more through incremental development of your product, through research, through prototyping, whatever. One of the things I do with my classes is I have actually sent out something ahead of time. I'm thinking about developing a class on. Let me know if you're interested. And I literally do a market survey. And if nobody or very few people respond back that they're interested in such a class, then it's not worth my developing it. That kind of thing.
Okay. We have reached the end of the questions in the chat. Does anyone else have a question they want to ask Linda prior to moving on? We just received a thank you. So thank you for your presentation, Linda, in the chat.
Okay. And I wanted to show one more thing.
Sure, of course. Oh, that's cool.
That's a Maltese multi-break shell. I mentioned Malta as we were talking earlier, but that shell took me 40 hours to build.
Oh my goodness. That's wow.
So I just thought,
And-
since there was some interest in the fireworks, I thought I'd show you one more before we quit.
And
Yeah, that was cool.
like that, it was gone.
Yeah.
Yeah.
40 hours worth of work and 15 seconds worth of beauty in the sky.
Oh man. It was beautiful though, for sure.
Well, I need to give
All
you
right, well, I
back.
guess that concludes, oh, let me check one more time. I think so, yep, that concludes the questions from the audience, so.
I think I need to stop sharing if I'm doing this right. Where's the button to stop sharing?
It's right above the taskbar for Zoom. It says there's like a green,
Yeah, I
a
see
small,
that. I don't know. I'm clicking on. I don't see the thing that says stop sharing anymore. Oh, there it is. It's red. I'm
Yep.
looking at the green stuff. Stop sharing. Okay, it should be back to you.
okay,
And
perfect.
I see your screen.
All right, great. Thank you, Linda. And thank you for your presentation tonight. We really appreciate it. It was very informative.
Thank you for inviting me.
If you,
You can't
of
tell I'm
course,
passionate about this stuff.
just a little bit, just a little bit. It's great. If you'd like to stay on with us, you're more than welcome. We just have a few additional announcement slides and then we close for the evening. I just need to figure out where to start my slideshow. Here we go. All right. So just a few wrap-up comments. As I mentioned, meeting evaluation surveys, please complete the event satisfaction survey. You'll find the survey link in your electronic RU certificate in the thank you email from our VOC chair, Chuck Cox. This is also the same individual that you email if you would like RU certificates after watching a recorded program online. Our 2024 program schedule, we are currently trying to provide you with 12 hybrid in-person virtual meetings, 4 per quarter, or actually 3 per quarter with a guest speaker. So 12 total. My math was clearly off there. 1 tour of a company, winery, or brewery, which would be in-person only. That would be an in-person networking event. And then 1 community outreach event, such as Feed My Starving Children, Habitat for Humanity, etc. Last year we did Feed My Starving Children and had a great time. Coming up on April 11th, we have a panel discussion on semiconductor quality that is going to be led, well, that's going to be provided by 4 individuals from Northern Arizona University. We have Dr. Andy Wong, Dr. Miguel Jose Yacaman, and Dr. Carlo DeCuna, who will be on the panel, and the panel will be moderated by Lauren Major. So we're taking a slightly different approach for our presentation next month and hope you'll join us for it. Let's see. And you can find the ASQ Phoenix section on various social media platforms. We're on Facebook, we're on LinkedIn, we're on X, YouTube, and Instagram. So if you are on social media, check us out on one of those platforms. Are there any final thoughts, comments, or questions prior to disbanding for the evening? All right. And we'll take the silence as a no.
Thank you all for having me.
Yeah, thank you for
Thank you.
thank you
Thank
for
you.
joining us. All
Good
right,
times.
everyone. Thank you for attendance. Be safe, stay healthy, and please join us next month. And please complete your satisfaction survey. All right, have a good night.
All right, thanks.